Let's solve x to the 2/3 plus 2 times x to the 1/3 minus 8 equals 0. I know this equation looks a little strange, but we're going to do just a quick rewrite first. So that first term, which said x to the 2/3, you can call that x to the 1/3's quantity to the second power, right? Because you can multiply exponents here, right? Base raised to an exponent, quantity raised to an exponent. You'd multiply 1/3 and 2, and that would be 2/3. So that's it. That's the only thing that was rewritten. Otherwise, the next term plus 2x to the 1/3 minus 8 equals 0, that all looks the same, other than, sorry for the little gap of space, it was just because of the coloring here. You see x to the 1/3 written in two places, and those are in yellow here. We are going to now replace each x to the 1/3 with a z, and then we'll solve for z. So first let's replace with a z. Okay, so z to the second plus 2z minus 8 equals 0. Now let's solve for z. Take this equation, z squared plus 2z minus 8 equals 0, that's quadratic. This is, the left side's going to factor nice. So z plus 4 times z minus 2 equals 0. Apply the zero product property. Subtract 4 on both sides of the first equation. Add 2 on both sides of the next equation. So we have z equals negative 4 or z equals 2. Now we have solved for z. And now these z's, which are in blue, now that we've solved for z, we're going to replace z back the other way with x to the 1/3. Because earlier, at the box towards the top, we replaced each x to the 1/3 with a z. Now we're going to just do that in reverse. Replace each z with x to the 1/3. That's all that happened here. Each z from the line above is back to an x to the 1/3. So x to the 1/3 equals negative 4, or x to the 1/3 equals 2. And just to rewrite both of those x to the 1/3, it's just a cube root of x for both of those. We didn't do anything to both sides. We just rewrote x to the 1/3 as cube root of x. Now to undo a cube root, we have to cube. So we're going to cube both sides of both equations and get x equals negative 4 quantity to the third, or x equals 2 to the third. And those will simplify to be x equals negative 64, or x equals 8. Let's try this process again. Let's discuss the strategy that you saw by example here. If you see an expression repeated, so like in our first line of the answer, x to the 1/3 appeared, temporarily replace with a new variable. In our example, z replaces x to the 1/3. Then solve for the new variable. That's key. You've got to solve for the new variable. So there are all these steps to get to here, and then you replace back. So that's here's where we replace back the other way. Each z, once we solved for z, got replaced with x to the 1/3. So this strategy, again, if you see an expression repeated, temporarily replace with a new variable, solve for the new variable, and then replace back. The substitution, by the way, must get rid of the old variable entirely. Let's try another example. X to the 6th minus 9x to the 3rd plus 18 equals 0. Now there's no repeated expression as written, but what's a nice way to rewrite the first term so that we have repetition? We could write x to the 6th as x to the 3rd quantity to the 2nd. Right? This is the situation we'd multiply exponents. So x to the 3rd, quantity to the 2nd, minus 9x to the 3rd plus 18 equals 0. So you see this x to the 3rd written in two places, and we'll make a replacement. Okay, we're going to substitute every x to the 3rd we see with a u instead. So we have u squared minus 9u plus 18 equals 0. This is a quadratic equation just in the variable u. We need to solve for u. Okay, so let's factor. U minus 3 times u minus 6 equals 0. Apply the zero product property. U minus 3 equals 0, or u minus 6 equals 0. Add 3 to both sides on one equation. Add 6 to both sides on the other equation. Now look, we've solved for u. It's only now at this stage, now that we have solved for u, we do the next thing. So now that we have solved for u, we can replace each u with an x cubed. Earlier, towards the beginning, right after the first line of the answer, we replaced every x cubed with a u. Now it's time to replace each u with an x cubed. We're replacing back just from instead of every x cubed becoming a u, now every u becomes an x cubed. So we end up with x cubed equals 3, or x cubed equals 6. And now to solve for x, we just need to cube root both sides of both equations. So we'll have x equals cube root of 3, or x equals cube root of 6, and we are done. Sometimes people think that the first thing, cube root of 3, ought to simplify to 1, and it doesn't. Or that the cube root of 6 should simplify to 2, and it doesn't. Think of what a cube root really means.